Hi, how do we do mass to mass conversion in a stoichiometry problem? Now I'll be showing to you how to do the mass to mass from mass to A to mass to B using the stoichiometry roadmap. If you look at the roadmap, you would see that you can't right away go to massive B from massive A. This will require three steps, and these are the three steps. Based on the roadmap, you would see that the first conversion will be using the molar mass of your A, and then to be followed by the mole ratio or the stoichiometric factor, which will come from the coefficient values between the given substance and the substance you require. And then right after that, to get the mass of the substance you're looking for, you need to look at or you need to multiply it with the molar mass of B. So to shortcut that, the outline for that particular conversion from mass to mass is that you begin with molar mass of A to be followed by the mole ratio of A and B and then the molar mass of B. So three conversion factors. Now let's look at this problem that has already been solved beforehand. This is the problem of propane gas that combusts in the presence of oxygen gas. So in the given, you know that it's C3H8. This is your propane that reacts with oxygen gas, forming water and carbon dioxide. You know that the equation is not balanced, so therefore we need to put the coefficient so that the number of atoms before and after the reaction will be the same. So the coefficients are 1, 5, 4, and 3. I want you to pause this video and I want you to check whether the equation is balanced and whether you can recall how to balance a combustion reaction. Now that you're able to check that the equation is balanced, now let us go to the problem. The problem says how many grams of carbon dioxide form when there are 20 grams of oxygen gas that react with your propane. So always in the problem, in stoichiometry problem, you have to know where to begin. You begin with what is given, with the value you're given at, so that will give you an identity of your given substance, and then you know what you're looking for. So in this case, we begin obviously with your 20 grams of oxygen gas, and then we should end up with grams of carbon dioxide, in which grams is the unit of mass. Therefore, this is a mass to mass conversion. So we begin with always the given, which is 20 grams of O2. So 20 grams of O2, the first thing is we need to divide it by the molar mass value of your O2. Take note, O2, there's two oxygen gas, so 2 times 16. Therefore, the molar mass of that is 32 grams. Never include the coefficient 5 in calculating for the molar mass. The 5 coefficient is for mole ratio, not for molar mass. But always do include the subscript in the calculation of your molar mass. So again, for the molar mass of O2, it's 32 grams below, so you can cancel out the grams O2 given, and then the 1 mole on top so that you can get the mole of O2. Remember that when we talk about molar mass, it's always the mass in grams of that particular substance in every mole of that. So in every mole, that means it's always 1 mole for for the gram value that it has. So it's always partnered with 1 mole. So the next step after the molar mass of O2 is the mole ratio between your O2 and the one you're looking for, which is CO2. So the mole ratio based from the balanced chemical equation is 5 and 3. 5 for O2 and 3 for CO2. Now, where will we place the O2 and CO2? Take note, you need to cancel out mole O2. So therefore, the 5 moles O2 has to be in the denominator, and obviously, your 3 moles of CO2 has to be on top. Okay? Now, this will cancel out mole O2 and mole O2 from the molar mass. And then you get mole CO2, but we need the mass of CO2. So the last step will be to multiply it with the molar mass of CO2, which is 1 carbon and 2 oxygen, and we never included the 3 coefficient in the molar mass calculation, so it's just CO2. We will get 44.01 grams. So the grams has to be on top and the 1 mole has to be below so that we can cancel out the mole CO2 from the mole ratio. And in the end, we will get the desired unit, which is grams. So you have gram CO2 as the final unit. So putting all of this in the calculator, take note for one time inputting in the calculator, make use of the parentheses function in your calculator and enclose all the numerators together in that parentheses divided by another parentheses for the denominator so that you can calculate it at once and you avoid rounding up or dropping values in between the calculation. You would ensure that you put them all in one entry in the calculator and you will get the most accurate answer. So input this in the calculator, open parentheses, 20 times 3 times 44.01, close parentheses, press divide, open parentheses, 32 times 5, close parentheses, and then equal sign. Then you will get 16.50 grams CO2 as the final answer, expressed in two decimal places. Please pause now and try to check these computations. And as much as possible, may I ask you to take note of these problems, copy it in your notes, and try it out for yourself so you can have application and real time experience on mass to mass conversion. Okay, and now, just to wrap up mass to mass conversion, so if it's mass to mass, it always deals with three steps. What are these steps? You have your molar mass of the given, followed by the mole ratio between the given and the required, and then the last will be the molar mass of your required substance. So basically, that's it for mass to mass conversion. Please don't fail to apply what you learned in this video. Thank you so much. Bye.